Imagine a world where solar panels never stop working. No clouds, no nighttime, no seasonal variations. Just pure constant sunlight. 24 hours a day, 7 days a week. This isn't science fiction, it's space-based solar power. And it's been almost here for over 80 years. So why aren't we doing it yet? The idea started with science fiction legend Isaac Asimov. In his 1941 short story Reason, he imagined astronauts operating a solar energy station in space that beamed power across the solar system. It was pure fantasy then, but by the 1960s, scientists were already developing real technologies to make it happen. Decades passed, we put humans on the moon, we built the International Space Station, we developed reusable rockets. Yet space-based solar power remains elusive. To understand why, we must look at what it actually takes to build solar panels in orbit. Building a space-based solar farm requires 3 major steps. First, you design and manufacture massive solar panel components here on Earth. Second, you launch those components into orbit using many rockets. Each launch costs millions of dollars and releases significant emissions. Third, robots assemble these pieces into a giant structure in space. We're talking about solar farms potentially the size of entire cities, floating 22,000 miles above Earth. Finally, the system captures sunlight and transmits it wirelessly using microwaves down to ground stations on Earth, where it's converted back into electricity for the grid. Sanjay Vijendran is a true believer. As co-founder and CTO of TerraSpark, a European space-based solar energy company, he's betting his career on this technology. According to Vijendran, the timing is finally right. Quote, "If you go up into space where the sun is shining 24/7, you can capture clean energy in a reliable way that is available for the next 5 billion years." He argues that reusable rockets and mass production of satellites have made the economics viable for the first time in history. A 2025 study from King's College London suggests space-based solar power could reduce Europe's need for land-based renewable energy by up to 80%. Imagine freeing up that much land for agriculture, forests, or cities. But not everyone is convinced. In 2024, NASA released a sobering analysis. They found that the space-based energy systems they studied are costly and may produce greenhouse gas emissions comparable to existing renewable energy on Earth. Professor Francesco Contino from UC Leuven in Belgium takes an even harder stance. Quote, "It feels a bit like a race forward when we should be thinking about slowing down. Going forward together in our society is to look for sufficiency and not to explore new ways to get more and more energy. Then there are the practical concerns, debris collision risks, massive financial investments, and a big question. Will the public accept giant energy beams firing down from space?" In 2022, the European Space Agency launched SpaceVrse, an ambitious 3-year program to prepare Europe for space-based solar power. Sanjay Vijendran was one of the main leaders. The project generated enormous public interest and international media coverage. So space-based solar power remains in limbo, promising but unproven, visionary but expensive. It's been almost here since 1941. Will it finally arrive in the next decade? Or will we decide that the best place for solar panels is here on Earth? Only time will tell.